Hi everyone, welcome to part 2 of our camera system prototype. On the last video we created a simple blueprint that housed a scene capture component that writes the video feed to a rendered target texture we set up. In this video we'll give a little bit more life to our blueprint. We'll change it from a static view to a scanning view, and we'll feed that into our target texture in real time. So let's go ahead and get into it. Alright, so going back into our blueprint, we have just a basic camera, but we need to kind of move it around and get like a scan of our environment. So let's go to our event graph, and to basically complete this, we're going to be going off our begin play. So we'll drag off here and we'll create a timeline, and we'll call it camera movement, or whatever you want to name it. We're also going to want to get some variables. So looking into our scene for our actual, actually let me find it here, our blueprint. Collapse some of these other things here. There we go, our camera. Alright, so the camera, we're going to be modifying the pitch and the yaw, but we're not going to be messing with the roll. So we're going to be using rotation values to actually achieve this. So we'll basically pitch it down a bit, and then we'll rotate the yaw from, maybe 70 or 80 degrees, and then we'll go from a positive to a negative value. So we can multiply whatever yaw we set by -1, and that'll be how we set up, the rotation from like left to right. So some variables we'll need to set up are going to be our camera pitch. And because these are angles, we're going to want to set this to a float. When you set up the camera pitch, let's make this instance editable, because if you're making a project and you're setting up multiple cameras, maybe the cameras will have different rotation values. Like maybe one will scan, like 60 or 70 degrees, and then you might have one that scans 180 degrees. And you might have different pitches, right? One might be looking straight down, the other one might only be looking down 20 degrees. So we'll just make these instance editable on each object so we can change it without having to update our code manually. So there's our pitch, and this will be our camera yaw. And instance editable right there. Default values will be set at 0 because we'll set them in the level blueprint. Well, not in the level blueprint, but in the level when we actually set them out. All right, so to get the rotation, what we're going to do off our timeline is basically you can get a reference to your camera object, and then you could just simply drag off that and do a set relative rotation. And then you just hook up your execution pins there. So this code will control the rotation of the camera, including the roll, pitch, and yaw. The timeline will control how smooth the transition happens, and will basically how fast and how, it won't control how smooth, it'll control how fast or slow you actually move the camera from left to right. And then the way we're going to be moving the camera, since we're going to be working with rotations, we're just going to basically use a lerp rotator. This guy right here. So the way he works is you give him 2 sets of rotations, and then you blend between the values using an alpha. And the alpha is going to be between 0 and 1. And you can kind of see that in the description there. So our alpha we will get from our camera movement. So we'll create an alpha channel in our camera movement, and that'll be based on the timeline we set up. And that'll affect the actual lerp rotator. So let's move this over. We'll connect this guy up here, and we'll kind of prepare the setup. So obviously we need 2 rotators, so we're gonna have to make 2 rotators. So make rotator. So there's our first one. Let's drag this down a little bit further, and then we'll make our second one. And we're going to be getting our camera pitch and our camera yaw. Remember, we're not messing with the roll. We're not going to make the camera roll, basically. So, I mean, you could if you wanted to, but doesn't really seem necessary. All right. So the camera pitch, we're just going to basically plug straight in because we're going to set that in game, and we're not going to really modify that much. We'll modify it based on instance, but not actually in. We will maybe in a later implementation. I'll do a video on like tracking an intruder, so we'll modify it there. But just for the simple scanning setup, nothing's really going to change. And then the camera yaw for the first rotator, you'll just plug in your static value. But on the second one, we'll want to multiply it by -1 to get the opposite end of the rotation. So if you're setting it to 80 degrees, this will be -80 degrees, and then you'll swing from 80 to -80. Or if you're doing 70 or 60 or whatever. All right, and then from there we can plug in our bottom rotator into the lerp, and then our top rotator. And that's gonna basically be our values for that. So pretty simple setup. This will be the majority of the code just for the swinging, but we still need to set up our timeline because we haven't done that yet. So let's head over. You can just double click on the timeline and it'll bring up your graph editor. And we're gonna add a float track. And I'm going to call this the cam alpha. Now for my timeline, I think I'm going to do a 13-second timeline. And I'm basically going to go between the values of 0 and 1, because if you remember on our lerp node, the alpha channel is basically 0 and 1. So I only need to swing between those two values. If you're doing something else like opening a door or moving an object or transforming, your values can obviously differ. But yeah, so we'll right click, we'll create a key at time 0. I'm going to make the value 0. I want to wait a second and do nothing. So I'm going to add a key, and at second 1, I'm going to set the time to 0 as well. And then I'm going to say at time 5, I want to make it to the full transition, the rotation. So I'm going to set the alpha to 1. So you can see that kind of here. Now, whatever timeline you make for your camera, because you can kind of do this however you want, just make it symmetrical to get a nice, even, smooth transition from left to right. I mean, you could make it uneven, but then you're going to get very weird camera movement. Maybe that's what you want, but just be advised, if you're looking for smooth movement, you'd want to make whatever you're doing symmetrical. Okay, so at time 1, I moved to 5, so that's a value or a difference of 4 for our change in time. So I think I'm going to keep this position for 3 seconds. So I'll do time 8 and then set it to 1 so nothing happens. And then I'm going to do time 12 back to 0. And the reason I did that is because between 1 and 5 is 4, between 8 and 12 is 4 as well. So I'm just making it symmetrical. And then just to get the last keyframe, that's obviously going to be at time 13. And we're going to set it at 0. And that's going to be my basic timeline. So nothing too crazy there. The other options I'm going to enable is I'm going to tell this to auto execute when it's created, so autoplay. And I'm also going to change it to loop, so it does it forever. Compile and save. And yeah, that's basically the majority of the code here. So I can maybe grab this guy and move it up here. Move this guy down here. All right, now if you notice in our timeline, when we named our track, our float track, we called it cam alpha. Whatever you name it there is what's going to show up right here. So because this is going to be our alpha value, we'll plug it into our alpha channel on our lerp node. And then we can select everything, give it a comment, and we'll just call this our camera passive look. Or whatever you want to name it. I guess it doesn't matter too much. But if we go back and we play, nothing should happen. It shouldn't move. And that should make sense, right? Yeah, nothing's happening. And the reason nothing's happening is because we're getting a pitch and yaw of, so if we select our camera here and we go over, we made it instance editable, so these values show up here. So the pitch and yaw currently is 0 degrees and 0 degrees. So we're telling it to, you know, take a pitch of 0 and a yaw of 0 and a roll of 0 and lerp between that value and a value of 0, 0, and 0 times -1 is 0. So it's basically lerping between nothing. So that's why you're not getting any movement. So if you go in here and you set some values, like say we want to pitch it down 20 degrees, and then your yaw, which is your left and right, say you wanted to go 80 degrees. So now if you compile and save and actually play, it should be moving. And there you go. Goes basically based on the timeline is that alpha channel, so you can see it kind of going through and moving pretty nicely. Yeah. All right, everyone. We'll cut it here to keep the video series in small bite-sized chunks. I'm going to expand out the camera system prototype in further videos, so be sure to look for those. We'll be doing collision checking and tracking in the next one. But yeah, if you found any informative value in this topic, please consider leaving a like and a sub to help me grow the channel. Also, feel free to leave a comment on any future topics you want covered. As always, thanks for watching, and see you on the next one.